Hi, this is Lalit Gajre. I'm the track chair for the AI Skills Lab. So now we are going to start the AI Skills Lab, conducted by two experts from Google Cloud, Lak Lakshmanan and Anu Srivastava. First hour will be conducted by Anu Srivastava, who works in developer relations for Google Cloud in New York. She advocates for developers building with AI ML APIs to boost their services and workflows. She previously worked as a software engineer on Android in California Bay Area. In her free time, she likes to perform with a dance group in Manhattan. Anu, take over.
Great. Okay. Hi, everyone. Thank you so much for joining me this morning or whatever hour it might be for you where you're located. My name is Anu Srivastava. Thank you so much for the great introduction. I work in cloud developer relations at Google. So I specifically focus on artificial intelligence. And we get to go to the community and serve as a two-way street for basically talking about new technologies, explaining how to use them, getting hands on keyboard, trying them out. But then also, please send me all of your feedback because we use this feedback, we take it back to the engineering teams to build and make these products better over time. So you might be familiar with several of Google Cloud AI's offerings, such as Vision, NLP, custom models, our AI platform. Well, I'm really excited to talk to you today about Document AI. So what is Document AI? So Document AI is a solution that allows you to unlock insights from documents with machine learning. So Doc AI includes a platform, tooling, and a set of specialized solutions that can tie it all together to solve data extraction and automating workflows. So let's get started. So during the hands-on portion, we will be coding together in Jupyter Notebooks. So if you'd like to get one started, please feel free to do so. I know sometimes they can take a minute or two to provision, but don't worry, we're going to do this all together and the recording will be available afterwards if you'd like to replay all of the steps. So before we dive into really what is Document AI and how can I use it, let's take a step back and understand the why. Why has Google invested in building a robust machine learning-based document processing platform? Well, some of the most data in companies isn't already in a structured database, but rather in documents. Transforming documents into structured data helps companies increase the speed of their decision making, reduce costs related to manual data entry, and develop better experiences for their customers. So we're not trying to replace humans. We're just trying to allow us to unlock doing more valuable things as part of our day-to-day jobs. So when we say documents, we actually include everything from PDFs, emails, images, and more. Think about all the contracts, patent documents, business attachments that you've worked with probably already today, but that they're in difficult to parse formats. So this is what we like to call dark data. So dark data is information assets or organizations collect to process and they store during regular business activities, but that we generally fail to use for other purposes. So maybe you're storing all this data for compliance or some other reason, but you're not actually analyzing or using this information to directly monetize. So Doc AI can help you safely and securely use this data. So you can expect the same compliance standards that we have for all the other services we have on GCP. In fact, if you're in finance or healthcare, I encourage you to actually look at the compliance resource center that we have in the Google Cloud documentation, which can explain in more detail, how we're able to do this and be compatible with other systems. So I will bring that up later, but yeah, let's keep going. So in the past year, we've really had to go digital, right? So the compliance with data the problem with data is really only going to grow. So even with digital documents, you can spend a lot of time and money on processing and analysis. When you have workflows with several manual steps, this can be prone to inaccuracies. So this is where Document AI comes in. Use the service to turn your unstructured content into structured data. Here's a good example. There have been several studies really trying to understand this unstructured data problem. In fact, I believe that there's a Forbes article that estimates only about 20% of enterprise data is in a format that a computer could easily understand and utilize. The 80% is unstructured, which means expensive and difficult to harness. And that's what we're trying to solve today. So Doc AI really lets you tackle the end-to-end. So not only does it read and ingest your documents, it understands them. It understands the spatial structure, the input of the document. So for example, let's say you're writing some sort of form questionnaire, not a common business type. You could still run it through this parser. And then because of the layout structure, Doc AI understands that you really have a series of questions and answers. So you get those back in structured key value pairs in your API response, which is much more easier to work with programmatically, as a developer versus just, straight out of the box OCR. So the point is that with structured data, you can really do number 3, making it useful. So maybe you want to run analytics on this. Maybe you're doing things with data science. I'm a developer, so I'm envisioning, I have dashboards for monitoring different things during my day-to-day business. What if I want to add another data stream into this? So this is a way to incorporate documents into your existing app or service via the API. So, don't worry if you're working on an on-prem or a hybrid system. You can still use this API where your code is running. It's fine if you're working it on another cloud provider. This API is still available for your use. So now let's start to really break it down. So first we have general document AI. So this has OCR that we've actually specifically trained on document types. And we have a structured form parser, but there's also some tooling to help you with this. So we have, if you're uploading a multi-page document, we have splitters. We can also identify and classify different document types. It's great when we do demos where we're, parsing 1 or 2 documents, but to really use this at scale, right? In production, you want to be processing lots of documents and automating as much as possible and using your input sources in the ROS format that you have. So that might be, uploading 1,000-page documents, that sort of thing. Then in the middle, we have our AutoML route. So if you want to train on your own document types. Then on the right, we have the specialized document AI. This is something I'm really excited to talk about a bit later. But for specialized, we have models specifically for several common enterprise document types. So think about, tax forms, W-2s, W-9s. If you're America, tax day is actually coming up soon. But we also have models for other common business form types like payslips, bank statements. And this includes very high variance document types like invoices and receipts. Invoices can look very different from each other. So Google trains and maintains these models so you don't have to. So today we're going to focus on general and specialized. We will lay the foundation and get a sense of the new platform in the console and how the API works. Then we'll talk about specialized solutions after. So let's start with general doc AI. Then we'll transition to specialized. So today what we're going to demo is actually our form parser. And I mentioned how we can pull out structured key value pairs and make extracting data from the response body easy. So we're going to do this together, actually. So if you should have Google Cloud credits or set up in your Qwiklabs environment, we're going to do a couple of things that I will do in my browser simultaneously. So the first thing, I would love it if you could open 2 different tabs. So one to the Google Cloud Console. This is where we can control and manage all of our Google services, including Document AI. And this is where our environment will be for our hands-on portion. And then second, I have this bit.ly link down here. So doc-ai-workshop. So what we've done is ahead of time, I prepared a couple Jupyter notebooks with a lot of the code set up. So we're going to import this into our environment, set up Doc AI, and then we'll actually do the demo together. And in this GitHub repository, you'll actually see that we have several different Jupyter notebooks that you can test out different variations of Doc.ai. And we even have some sample forms for you to use so you can get a good sense of the product in its different capabilities. So great. So first, console.cloud.google.com, and then this bit.ly link. It's actually Google Cloud Platform Document AI Notebooks is a GitHub repository. Don't worry, we're not going to do anything too complex with GitHub. It's just we're using this to get the code. No pull requests, no merges, anything like that. So let's first go to the console. So this is the homepage of Google Cloud where I can enable services, I can manage them, manage my billing, etc. The first thing that we're going to do, I'm going to call this step 0, is actually set up our environment. So what you can do in here is in the search bar, search for notebooks. We're going to create a Python environment. Don't worry if you're not familiar with Python. The code actually we provided has everything set up, and we're just going to copy and paste in some of our variables, some of our strings that we need to actually run it. What I really like about using these notebooks in Google Cloud, the console, is that because you're already logged in, you already have everything set up, it actually handles a lot of the authentication for you. This will be different when you're working in your production system, especially if you're working on-prem or on cloud, something like that. But just for the purposes of getting a sense of Doc.ai, let's start here. So once you go to this notebook page, what you can do is hit New Instance, and then go here and select Python 3. So just set one up. We're not doing anything crazy with all the default environment variables. So I'm going to call this live TiEcon. You can name it whatever you feel like it. This actually takes a minute or two to provision. So while this is running, let's do a couple things. We're going to set up Document AI, and then in the console, we're actually able to test a sample document and see how it would look when we're actually doing it in our production service. So step 1. Let's go here, and then let's download a sample document to try out together. So if you go to the resources directory, we have different sets of documents for all the different types of specialized models available. We're going to be working with the generic form parser right now. So go to General, and then I have this document called form.tiff. And then just go ahead and hit download. I'll show you what it looks like. I'll show you what it looks like in a second. But this is compatible with multiple different form types. You normally think of PDF with this, but it actually supports image formats as well. So now that you have that downloaded, let's go back to the console, and then let's set up Document AI and upload it. So I'm going to leave this open and then just open another tab with the Google Cloud Console in it. And then let's get started finally setting up Doc AI. So in your search bar, type in Document AI, and then go here. So if you have never done this before, you will get a screen that says that you need to enable the Document AI API. I actually, wanted to make sure everything was going to run smooth for this morning, so I tested it out earlier today. So when you see the screen that says enable, hit enable, and then it will take you to this page. This is the home page, the entryway to the Document AI platform. So here is where you can create, delete, manage your different processors. There's a couple of different components and the tooling. Everything goes in here. So the first thing that we're going to do is create our first processor. Oops. Thank you, everyone. Great. So Here is our directory of all of the different processors and tools that you can use and work with. So in the top level, here we have some of the tooling I mentioned earlier. So if you do actually only need OCR for maybe handwritten forms or, really a model tuned to form types, even if they're typed, we recommend using document OCR. So this is a little better than if you were, say, using Vision OCR, which is trained a little bit differently. This one, it really hones in on this document use case. Then we have the doc splitter. So this you can use to intelligently understand where different doc types start and end, so you can split them apart and then run them through the appropriate parser. Form parser is what we're working with first. But if you scroll down here to specialize, you can see these common business form types that I was talking about. So there's quite a few here right now. All of these have models specifically for that form type behind them that the team is actively growing and fine-tuning, and more are on the way. So check back every month or so, and you'll definitely see new ones. So let's go ahead and click Form Parser and get started. Okay, so here I have this panel where I'm going to create it. So I'm just going to call it Forms Demo. I'm located in the US, but something I think is really important is, if you are maybe based in EMEA or you have some data locality restrictions, you can specify that it's created in the European Union. What is great about this is that once you pick a region, your data actually doesn't leave that region. And when you actually create the client itself in your code, you have to specify the matching location, and that way nothing will actually leave that data region. So I'm going to hit US, but you can try out the EU endpoint as well. They're identical. They're just different instances running. And then there's a few other options, in case you need to use a different encryption key. So I'm going to hit create. Okay, great. Wow, that was really quickly. That was really quick. So now we are in our view of this specific processor. I can see here the name that I specified earlier. And then here is this ID. This is the ID for this specific instance of a processor. Some of the terminology we use is when we're talking about a form type in general, we'll talk about the parser. But then when we actually create an instance of it, object-oriented programming, it becomes a processor. So this is my processor. I can see that it's enabled, and I'm using just the default Google Managed key. And then here is the prediction endpoint. So these variables, we're going to keep up because we're going to need them in our code in a little bit. But let's do something fun and actually visually inspect what my test form would look like. Okay, so here is my form.tiff from earlier. You can kind of see that it has a black background. It's slightly askew, and you can see that I digitally added a coffee stain on it. And once it's uploaded, you can see that the handwriting on it is actually quite faint. So let's see what the processor can do with it. So here we go. We've uploaded it. Doc AI isn't thrown off just because the it's askew. It's not really what a human or a machine is ready to process, but it's still able to pull out things like, look, the date. You not only get the extracted data with Document AI, and we'll talk about this. You actually get what we call this doc.proto, which is this unified document representation format that we're rolling out to other services on the Google platform, and will become a standard. So it'll help with interoperability, if you're using this data in other services. So we can inspect a few of the other fields, like it got the state just fine. So this layout information that you're getting back in the unified format, you can use this to integrate Document AI, say into a UI that you have. You can analyze, if you have different fonts and sizes and format, it's almost like the layout and structure of the document can be equally, if not more important than the text itself. So this is what it looks like. And now let's go ahead and do the same thing in our code. So by now, okay, great. So
Hey, Anu.
Yes.
Sorry, this is Lalit. So some attendees have they don't know where to go for this lab. So if you don't mind just pointing out the link again.
Oh yeah, sure. For where the code and the instructions are.
Yes.
Yeah, so they are available in this GitHub repository.
Do you mind just cut and paste that link in maybe the chat
Absolutely.
somewhere? Thank you.
If you could see this this GitHub, or actually I'll post it right here, bit.ly/doc-AI-workshop will take you to the GitHub repo that I'm talking about. And then actually all of the instructions are in the front page of that, the README, have how to set it up and then what variables you'll need to copy over, which is what we'll be doing together today. So I'll wait on this page for a couple seconds before flipping back over.
So just while we are waiting, this is Lalit. So just a quick comment. We have a lot of attendees, so it will be hard to kind of go one-on-one. So I think Anu will just go through the flow, and then if I think we may have the recording at later on. So and
Perfect.
I think I don't know, Anu, if you have any other way the attendee can learn more after this class, maybe go on your website.
Yeah. My CTA is definitely, all of this is in the documentation and the quick start, but specifically for using these notebooks, I just happen to be using notebooks in the Google Cloud environment. However, this is a Jupyter notebook. You can use, any Python notebook environment that that works best for you.
Okay, thank you. Yeah, please go ahead. Continue.
Yeah, definitely. So just to reiterate, doc-AI-workshop bit.ly link. And if you go here, you can even just search on GitHub for document-AI notebooks. All of the instructions are right here, even a visual of what we'll be doing in a little bit. And then there's some setup instructions here and some instructions that we're about to just do ourselves. So you can test it out yourself. So, okay, I'm going to open this Jupyter notebook that I have. And also, it's fine if you're using another notebook style. And then what we're going to do is we're actually going to, there's a mechanism to directly import all of this code, all of the sample data that we're going to be using. And it's fairly simple, I think. If you go back to this page, and then you hit code right here, and just copy this URL. It looks almost similar to the URL of the actual page, except that it has a .git at the end. So this is a file extension, so it actually understands that this is a repository. So just hit copy. And then here, if you go up to the top, there is a menu item called Git right there. Then what you can do is hit clone a repository and then paste it in there. Awesome. Okay. You can see that it made a folder called document-AI notebooks. So we go in here, and then I have everything already ready to go that we saw in the browser just a second ago. And resources is where we have sample docs for you to play around with. So like right here for mortgage tax lending forms, I have some W-2s. But we've set up everything ahead of time. So let's actually just get started with our first sample notebook, which is the form parser. So what I would love for you to do is inside this document-AI notebook folder, go to General. And then you'll see a file that's titled form underscore parser. And I can actually try to zoom in a bit if that'll help. Great. Okay, so the path is document-AI notebooks, general, and then form parser. Let's take a minute to inspect the code, and then we'll paste in those variables I mentioned earlier from the console, and then hit run. So if you've used Python before, if you're maybe a power user of Python, there's a way to sort of bundle your imports. So this is all of the libraries that we'll need to run this. So like the Document AI client library, the Google Cloud client library, how we do authentication and so forth, and this requirements.txt, just to let you know what that first line is. But this is going to install everything for us. Then we have our imports. Then here's a little bit of those setup variables. But let's actually get into the interesting thing, which is looking into the code. So first we have the client library right here. This is how we create it. And then we'll actually have to specify the endpoint. And as I talked about earlier with the location, mine just happens to be set to the US, but you can also set it to the EU. Then the first sort of setup thing we do is I've actually provided the local path of the test form that we have because it's already imported in for you. We're going to open up the image and then read it as bytes for how much is happening under the hood once you make this single API call. You know, it's vision, it's NLP, it's doing a lot of other things. It's actually a pretty simple API to use. So the API, the input parameters, all it needs is the image bytes as well as specifying the name of the processor. So that's what we saw earlier in the console. So then we'll make the API request, and then we'll go through the body and inspect the results after we run it. So just to give you a heads up, that's what the code is doing. Let's scroll up a little bit over here and let's add those variables so we can get started. So there are two things that I need. I need the project ID for my Google Cloud project that I'm in, and then we're going to need the processor ID of the instance of the form parser that I just created. So we're going to switch tabs over here. So let's first get the GCP project ID. This one is actually pretty easy to get because you can get it from anywhere you are in the console. If you go up here to the project selector, be sure that you're actually getting the ID. So my project is called document-AI. However, the project ID has this ID at the end. This is something we see a lot. I get bitten by it, whether you're using the project name or the ID. So I just wanted to spend a little bit of extra time on it. So I have that copy. Okay, great. And then the next thing that we'll need is this processor ID. So let's go here. And then back in this page where we have the processor, if you navigate it away, all you have to do is go back to the Document AI platform in the console and then hit this processors tab. And then you can navigate to the one that you just created and then copy this ID. Great. Okay, so I'm going to hit save. That's Control S for me. And now let's just run it and see what happens. So I'm going to run all cells. There's several buttons or command shortcuts you can do to run, but I'm just going to go to the run menu item and then go to run all cells. So here we can see it's downloading the client libraries and those packages that I need to be able to run this code. And then, okay, great. So we're going to scroll down and see the two things I wanted to output. So the first thing that we wanted to do is I wanted to go through the key value pairs that the API was able to pull out. And then something that you can do with the API that you can't actually see in the console, but could be important for your use case, is that you can inspect the confidence scores. So Doc.ai will extract the entities and then give you a score of how confident it is that the data extracted is this value. So you can make decisions based on, if a certain value is under a certain confidence score, maybe you need to have a human review or something like that. There's actually a mechanism for that called Human in the Loop AI, which is another new feature that launched actually only a couple weeks ago. We understand that, especially when you're working with important business documents at an enterprise, there's really no room for error. So to make sure that you have the highest accuracy, we have mechanisms in play for that. So with the form parser, you can see that these are the fields that we got. You're actually getting, the key itself, which is the question, and then the answer, which is the value. And I'll show you how we pull these out in the code. I just decided, since we're in this notebook, to use the sort of default way of presenting tabular data. But so up here, we have the result. That's the result from the API call. And then in the result object has, everything you'd need in any API call, which is like the status code, just the information for, making an HTTP call. But then the object that we want is the document object from the result. So that's what I mentioned is our new unified document standard. So this has all the information we need about the actual input that we gave it. So what you do for when you're using the generic form parser is that it will pull out all the information. It actually pulls out the layout information too, and then into these pages that we have in the document response. So the sample form that we're doing right now only has one page, but we'll show you another one later that is multi-page. So I go through each of the pages, and then I go through each of the form fields that we have, and then I add it to my table object, and then I print it out right here. So you have this code now. So please feel free to edit, modify, copy and paste using your system. I just want to explain what's going on there. So this is the structured tabular information. Now let's scroll down a little bit more, and then I can actually talk about that layout information that we saw in the console and how to do that and recreate that in the UI for your use case. So we have the bounding boxes. This comes in the layout information that the Document AI team has designed a format to return back. So you're getting layout pieces like tables, checkboxes, other things like that. And then you actually get what we call these bounding boxes back. So you'll get those coordinates, and then you can play with them yourself. So what I did is in this code right up here, which is image draw, these are generic, commonly used Python image packages. What I've done is I have drawn boxes around the keys in red, and then I've drawn boxes around the values in blue. And you can see, it's still able to pull things out, even though, there's a coffee stain, the color gradient is a little bit different. I actually intentionally, before uploading the sample document, I tried to, have like a contrast and like make it just, not really as precise as you'd expect for digital documents. So that is what we have for the form parser. What we did just now is we called the synchronous version of the API. So this is really good for, it's fast, it happens directly. But let's say you have this use case you want to do batch multiple documents, large workloads at a time. Maybe you're doing analytics. The use case I think of is, someone's, doing some analytics on this and importing the data into BigQuery. So for that, you probably don't want to use a synchronous API because you're going to lock up your resources. There is an asynchronous version of the API as well. So we're in form_parser. Then we have async form parser over here. So with async, you're actually able to inspect multiple documents at once. And then I'll show a diagram of this once we get back to the slides. But what you're able to do is, this is tightly integrated with Google Cloud Storage. So Google Cloud Storage is our blob store. You can store multimedia files in there. So the input, your documents will be in Google Cloud Storage, and then the JSON response that you get from the API will be stored there. So then what this code sample is going to do is going to tell you how to read that. What it's doing, it's just storing the document object in a JSON file. So then once it's done processing, since it's not happening synchronously, you just open up the JSON object and then you're able to read all of those same fields in there. So if you notice, this code actually looks pretty similar. We're going to set our project ID and our processor ID over here. I have some folders already set up. This one is actually public data. So it's readable by anyone on the internet. But I will show you how you can set up your output directories. So we'll go ahead and do that now. So to get to Google Cloud Storage, go here. Google Cloud Storage is, one of the oldest products in the Google Cloud family. There's a lot of text on it on the internet. So hopefully you're familiar with it, but if not, just feel free to search Google Cloud Storage, and there's great tutorials on here, out there. So Google Cloud Storage groups things into what we call buckets. And, buckets are, where you can have folders and files. So this is my test setup. So what I'll do is I'll be writing the output to these test directories. So let's actually go paste our variables in because it's async, so it can take a few minutes to actually process.
Anu, if I may add one more comment. So this is Lalit again. So at the end, we'll provide you a link to the attendees can sign up for some Google credits. And okay, it's controlled by Google, so we don't have a say, but we'll provide you the link where you have potentially can get $300 worth of credit. Okay, thank you.
Great, yeah. So I have just pasted in my variables. Same thing as before. We have our project ID. Then we have the processor ID. This is the same one I'm using for async that I have done for the synchronous one. Then there's a few other things that we're adding below, so we know where to find and write out the data. So this comes with the code sample that we provided. This is the readable one where we have 3 different forms in there. And then the output is where you would specify where you create your bucket, specify where you want that to be. And then you can scan this code, but it looks pretty similar. You're making a call to the API. There's a little bit of extra code here where we're iterating through the GCS bucket to make sure we pull out each individual document and then just sort of massage the input variable where it's located into the API response. Yeah, so for these notebooks that I drafted up, you don't actually have to write any code yourself, so you can just read it and learn it. But that's what you do, just paste in your variables and then you can hit run. So this is going to take a minute to run, and then you'll see at the end the tables. But I also just wanted to print out so you can see like cloud samples data. We're going to be analyzing a form, a medical form, and a driver's license. So this will take a couple minutes to run. I'll show you one that I ran actually this morning, so you know what you should see within a couple minutes. So we have a link to the forms if you want to visually inspect them yourself. They're in this GitHub repo, but you'll see a table for each of the form types. And again, same thing, you'll be able to see the confidence score for the key as well as the value. Something to note about the differences between the synchronous and the asynchronous API, which we'll go back to the slides now to talk more about that, is that we have some file size restrictions for the synchronous API, but they're much more generous for the asynchronous API. So you'll have to understand, you'll have to decide for you what makes sense for your architecture. So just so you get a sense of like what asynchronous looks like, because it's not really just a direct API call. I have my input files over here. They go to cloud storage. And then here is document AI. Then over here, they're actually going back out to cloud storage. And then I get that structured format with the intelligence in the JSON that I can then integrate into another system, whether that's some sort of database or maybe I have some application. That's where you get the API response to then use elsewhere. And I'm sure I'm going a little fast, but all of this is in the documentation, and we'll post the documentation in my last slide, so you can get started yourself. Now let's quickly talk about the specialized document AI flavor of document AI. So with specialized document AI, you get a lot of things. So this is a model specifically built for those form types that we mentioned earlier. And we even have special classifiers, that can identify, this is an invoice, this is a W-2, this is a W-9. So you can use this combination of tooling to really deeply integrate and use your so we call this. What it means is that you are not responsible for, maintaining a model of, invoices. Google is doing this, and we're actively growing and fine-tuning these models as we go. There are some solutions that might be of interest to you. So on top of the specialized parsers, we have a couple vertical solutions. So the first one is lending document AI. So this, the goal of lending document AI is this will transform the home loan experience for borrowers and lenders. If you've ever bought a house, you know that there's a lot of documents, and it's a long process because there's a lot of manual steps and different people involved. So the goal of this is, reduce processing time, streamline the data capture, and then most importantly, support regulatory and compliance requirements required by this industry. So this is where you'll see, a bundle of these form types that make sense for this use case. And here's the URL for it to get started: solutions lending-doc-ai. But if you go to your browser and search lending-doc-ai, it'll take you to this page. Here's one example company that has utilized doc-AI, lending-doc-ai, and that is Mr. Cooper. So they're processing large amounts of documents every day, and they need high accuracy. They have to manage, identify, extract data from mortgage documents, which are very, very domain specific. I don't work in this industry, so I really don't understand all the nuances there, but that's what the solution has been trained to help with. The next one I'd like to talk about is Procurement Doc-AI. So for procurement, think about invoices, receipts, utility statements, that sort of thing. Every business in the world has receipts and invoices. I will actually show the solution a little bit more in detail. Everyone's dealt with receipts. I remember, back when we were traveling a little bit more for work, I would have loved to have this to help me, make expense reports. Here, I'm going to go through a couple of sample architectures. You can really see examples of how to integrate this into your system. You could see this end to end, right? I would call this, a sample, one of the analytics use cases. Let's say you have an app, could be any sort of, mobile app, web app. Maybe you're using AppSheet, like a no-code platform. You're uploading documents, and then you put them into Google Cloud Storage, or if you're using the Synchronous API, wherever you store your customer data. Then you need to split and classify them. And then you run them through, that's a classify step with the tooling that we provide. Then you have extract. So that's where we get that data back in JSON, what we saw in our notebooks. And then you can integrate it with, BigQuery, or something that these solutions provide is what I think is a really neat add-on is that you get integrating with the Google Knowledge Graph, which is this sort of understanding that we use for search, right? So maybe you have a invoice with the logo, but it doesn't have the address. Well, Google knows that, like, based on that company, where the address is. So it'll fill in that information for you. And then you can integrate it with, maybe Looker for, business intelligence, or Data Studio. And then that's how you can share it across your company, or with other teams that you're working with. Here's another one. It's actually very similar. You get your documents, input them, and get them to the cloud. Maybe you're splitting invoices and receipts. Something really important I want to call out is this data loss prevention service. So data loss prevention is another service available on Google Cloud, and that can actually identify and redact sensitive information to help you make sure you're meeting the standards that you want. We have a little bit of glue, PubSub, to stream our data efficiently. You could really be integrating with any sort of storage solution. And then you go back to your app or web browser with that information. I'll actually show an example of output. I wanted to play around with a procurement document AI. So what I did is some of the sample invoices that we have in the repo, I ran them through Procurement Document AI. And then I personally enjoy working with Google Sheets using AppScript to automate that. So I created this tricks where I pulled out some of the pieces of information that I needed. And then I have this one tab where maybe I have a workflow where someone needs to come in and, process them or something. So I added a little bit of data validation. Now that I have this information here, I can do things like make charts, and I can either, share this directly, or maybe, there's a monthly report that I need to make every month. I can, link these in there, and I've saved a lot of manual work. So this is the goal for these solutions. I decided I wanted to. So now that you've gotten a taste of these specialized parsers, I'm going to quickly run through what happens under the hood, and then I'll save some time for questions now that we're ending the end of our session. Okay, great. So we're going to go through what happens when we actually make that API call and all the magic that's happening before the API response gets returned to you. So we do pre-process. As you saw earlier, it's okay if there's coffee stains or these are just images from, a mobile phone. We're going to do some, alignment, adjustment, in OCR to make sure that the machine can understand the text that's actually on it. Then if you're using the splitter and classifier, there's a great quick start on how to use this in the documentation. It'll identify, maybe pages 1 through 2 are an invoice, maybe pages 3, 4, 5, and 6 are receipts. It'll tell you that so you can then strip that all apart and then move it into the systems that make sense for those document types. Next, we have extract. So this is what we saw in our demo, where you're going to get either the key value pairs if it's a generic form parser, but if it is a specialized parser, you'll actually get what we call schematization. So in the case of the invoice, every invoice has an ID. It has line items. It has a receiver address, supplier address. Instead of regular key value pairs, it's going to be, entity and the entity value. So then you can just iterate through those. And this is really important for high variance documents. Some invoices might present the invoice ID, like ID colon something something, or some invoices might have, pound size and then the ID. What these models do is that they intelligently identify what values are what, and then they're merged into the schema. So you can expect consistency. You don't have to, add code for every sort of variation that you might expect. This is a real power of specialized processors. Something that I actually should have talked about a little bit more when we were looking in the sheet is entity normalization. So this is really, really key, and it shows a big difference between regular OCR because we're getting back this information. With OCR, you really just get it as a string. But we know that some of these fields are dates, or maybe they're monetary amounts, or maybe they're addresses. We know that in the schema. So what DocAI will return, in addition to the raw string, is that, say it's a monetary amount, it'll return it in a numerical format. So this is really important if you're integrating it into, a SQL database with types. It'd be better to have your line item amounts as a monetary value than as a string. In my spreadsheet I just showed, that's how I can show the dates as like a true date format compared to just a string. Because otherwise I can't make those charts or, more realistically put this into a database without adding additional code. And I don't know about you, but, converting formats is something that I feel like I have to do a lot. So this helps you sort of avoid that pain. You can check in our documentation. Here are some of the types that we normalize. So money, date value, date time, if you need that precision, and address value. We have a sample invoice. So this is what it's going to look like in the API response. You get this normalized value. And then as you can see, it's already pulled out all the different values that you need. So this can help you, specifically in this use case, showing dates in, different international formats. Okay, so now on to enrichment. I mentioned Google Knowledge Graph earlier. This is where the real understanding happens. You are able to supplement key pieces of information, even if they're not there. So I mentioned, it'll understand logos and maybe fill in addresses or like the line items. Something for invoices is that suppliers all have these supplier IDs. So this knowledge graph understands the procurement lifecycle and the process that you'll need, specifically for this use case. And this is a step where you get that. So last but not least, human review. So I mentioned earlier, right, with these business critical processes, everything needs to be as accurate as possible. So there is this new product called Human in the Loop AI. So you can configure it to where, if a certain field doesn't meet a certain confidence threshold, or maybe the whole document, I want to make sure every document that gets processed has like at least 98% accuracy. And if a document does not meet that accuracy, I can configure a pool of reviewers to validate that. So this is what we call a human in the loop AI, and there's a component of like how to set it up at your company, and that's how that tool works. So yeah, here's just a few points of why DocAI, things that I really like about it. I'm going to actually stop right here. Here's where you can get started: cloud.google.com, document-AI, and I would love to hear any questions that you have.
So I know the audience cannot ask audio questions. If you have anything in the Q&A, if you want to bring up, or we can just call it.
Oh, yeah, sure.
Okay, so I think yeah, thanks. This was a great session, Anu. Thanks for going over the GCP Google Cloud Platform options bring up. I do understand, it's a short time and we have a lot of attendees, so it will be hard to kind of go one-on-one with each questions. But overall, Anu, thanks. That was a great overview on Document AI.
Yeah, thank you.
Yep.
I think I actually didn't post my Twitter handle, but if you have any questions or would like to get in contact, I am very responsive on Twitter. My handle is @Shrivas_dev. I think it's probably posted somewhere. You can search my name. Feel free to send me questions about Doc AI. Would love to hear how you want to integrate it with your app or service. Please let me know.
Sure, thank you. And there were some questions about the video and slides. So for the video, we'll make them available in a few weeks' time. Just don't have an exact ETA for that. And for the slides, I'll check with both Anu and Lak later on if they're okay, and then let everybody know.
Great.
Okay, thanks, Anu, once again.
Thank you so much. I really appreciate it.
Thank you. Who's going to cover Explainable AI? Okay, I just was waiting for Lak's video.
Yeah,
Okay.
I'm here. Just a second. Yeah, thanks, Lilith. I'm just about sharing my screen.
Yep.
As Lilith mentioned. Yeah.
Lak, let me just introduce you if you don't mind.
No problem.
Yep. So again, sorry, just a little bit more on Lak. Lak is a director for data analytics and AI solutions at Google Cloud. His team builds software solutions for business problems using Google Cloud's data analytics and machine learning products. He founded Google's Advanced Solutions Lab ML Immersion program and is the author of 3 O'Reilly books and several Coursera courses, which I personally enjoyed. Before Google, Lak was a director of data science at Climate Corporation and a research scientist at NOAA. Over to you, Lak.
Yeah. Thanks, Lilith. And today I'm going to be talking about explainable AI on images, specifically how to explain what a machine learning model that's trained on images does. And so I'll talk about why we need explanations in the first place, go through some of the explainable AI methods that exist as far as images are concerned, and then talk about using explainable AI in Google Cloud, and finish off with a demo. Everything that I show you in the demo, there is a corresponding Qwiklab in which you can go try it out. All of the code that I'm going to be showing on the slides are part of this GitHub repository. So again, we'll share the slide deck with you, and you will be able to get the link from that. And for example, everything that I'm going to be showing you is actually in this 9F Explain IPython notebook, right? So it's about how to explain an image model, but it is part of a much longer set of notebooks, which I strongly encourage you to go look at. These are about all about how to train ML models, do object detection, and end-to-end training, deploying ML ops on image machine learning models. But why are we talking about explanations? Why do we need to explain machine learning models in the first place? Okay. Explainable AI is basically trying to address what is often called the black box problem in machine learning. People think that a machine learning model is a black box. I don't know what's going on in it. And that basically causes stakeholders, the people for whom you're building ML models, the ones that need to make decisions based on those machine learning models, to not trust the model. Imagine, for example, that you basically have a radiologist who's essentially looking at X-ray images, and you have a machine learning model that says this X-ray contains a broken bone. Well, they're not going to trust the ML model unless the ML model says something about why does the ML model believe that the bone is broken. And it could be as simple as marking which pixels of the image, right? Put a circle around the area where we think the broken bone exists. So that's one reason why we need explainability. It's to basically foster trust in the people using the ML models. The second reason is for us as developers of machine learning models. The internal logic of an ML model can be really hard. When we write software programs, if something doesn't work, we have a way of stepping through a debugger and figuring out what the logic is, where does the logic break down, and we basically get the ability to fix it. Well, how do we get that kind of troubleshooting capability in machine learning? And the way you do that is through explainability. There's a very famous case of a lot of okay, so there was this machine learning model that was built to identify the kinds of animals there are, and that machine learning model was essentially making a lot of mistakes when it came to dogs in winter situations. And it turned out that the reason was that the machine learning model had learned that most images of foxes happened to be when there was snow in the image, and most images of dogs happen to be in domestic settings. So it did not actually distinguish between dogs and foxes. It pretty much looked at the background of the images to determine if this was a fox or it was a dog. Well, how do you fix it? Well, the way you would fix it with machine learning is to do data augmentation. You would take the images that you already have of foxes and snow, cut out the foxes and put them in domestic situations, or take dogs from domestic situations and put them in snow-covered mountains. And that way you force the model to focus on the animal rather than on the background. So that's the second reason why you need explainable AI, to carry out troubleshooting, to figure out what is a model focusing on when it identifies something as a fox. The third reason why you need explainable AI is for bias busting, right? So for example, imagine that you have a camera mounted on top of a traffic intersection, and you want to identify people who are making left turns when they shouldn't be making left turns. And when you look at the image, it turns out, and you look at the explainability, it turns out that this model, which is meant to identify wrong left turns, is identifying potholes. It's really focusing on the presence or absence of potholes on the roads. Why would that be happening? Well, it may be because the model was trained on police giving tickets to people making left turns. And that was how we identified that this was a problem, and or that this was a wrong left turn. And the problem is that maybe there's a lot of police presence in the poorer areas of the city where there are lots of potholes. So now you basically have the model again amplifying bias when it shouldn't be amplifying bias. So three reasons: to foster trust in our stakeholders, to help us as the developers of ML models do troubleshooting, and thirdly, for doing bias busting to prevent amplifying sources of bias. So where can this happen? Where does bias occur? Where do mistakes happen? Well, they can happen at any stage, right? So, it could be in the data collection stage, it could be in the data processing stage in terms of labeling is wrong. It could be the data collection stage where we only had fox and snow, when we should have also collected images of foxes that are not in snowy situations, and dogs not just always in domestic situations, but also dogs outdoors. So that was a data collection thing. It could be in the case of a model training where we are using feature sets or we're using objective functions that are that overemphasize outliers, for example. It could happen during model evaluation where we're basically evaluating only a subset, right? Or it could happen during model serving because of complex feedback loops. The point is that it can happen in all of these places, and we need to basically identify it. So when it comes to images, what does it mean to say you have explainable AI, right? So here's a healthcare situation where you basically have a model that's basically trying to identify whether someone's eye is diseased or not, whether they have retinal disease or not. And what the explainable AI essentially says, here's the model and this is what it is focusing on. It's basically identifying the part of the image that the model focuses on to basically specify, to say whether or not that disease, that eye image has disease in it or not. Okay? There are other ways that you can do this, right? So you can also do this in terms of, should say, sliced evaluations, right? But you could do this on structured data. So if you have structured data you could basically go ahead and do the evaluation on different subsets of your images. You could do your evaluation, for example, in richer areas of the city, in poorer areas of the city, and see if the model basically has completely different objective measures. And the way you do that is you do that with something called the what if tool. Okay? But tends not to be the kind of thing that you do very much on images. The third thing that you can do for explainability is that you can build what are called model cards. So here, for example, is a model card from a model that basically is doing face detection. Is there a face in this image or not? And basically, it talks about the limitations of the model, the trade-offs of the model, the performance of the model on different skin tones, etc., etc. So that's an important best practice to have also, this ability to build model cards that tie together the explainable AI in terms of where in the image is it focusing on sliced evaluations to figure out how does a model perform on different slices of the population. So the point being that if explainability is very important, and it has to be part and parcel of your entire development process. Everything from where you're identifying and gathering data to when you have deployed the model and you're making predictions with it. So let's now talk about what methods exist if you want to do explainable AI. Okay? So there are two broad categories of methods when it comes to explaining machine learning models. The first one are global explanations. This is where you've trained an ML model with 23 features and you rank those features based on how important they are, feature importance. That's a global thing, right? This is how the model behaves on the complete training data set. The other type of explainability that you have is an instance explainability. That's the example that I showed you. Here is this prediction on this particular eye image. What does a model do on it? Okay. When it comes to explainability for troubleshooting, when it comes to explainability on trust, most likely what you want is an instance-based explainability. The feature importance is great, but it is not going to basically foster trust in the model other than in the aggregate. Right? This is going to help people understand what the model does in a broad sense, but it's really, really, really important to explain every individual prediction of the model. The instance explainability is extremely important when it comes to images. So for images, and if you want to be going ahead and doing explainability on each prediction, what methods do we have? Well, the methods that we have are LIME, local interpretable model agnostic explanation. I'll talk about what these are. The second one is called kernel SHAP. The third one I'll talk about is called integrated gradients. And the fourth one is called explainable regions through AI. Okay? So how does LIME or kernel SHAP, they're very similar. How do they work? The basic way that it works is that you take the image that you're carrying out the predictions on, and rather than simply say, okay, this image is a frog with a probability of 0.7, and people say, well, that's a black box. I don't know how you came up with that. We add some more explainability. And the way we do this is that we take the input image and we basically identify patches in that image. A patch is a set of pixels that all have approximately the same pixel value, right? So you basically found these patches in the image. And then what you do is that you randomly select a bunch of patches from the original image. So we call these perturbed images, perturbed meaning changed. So you've taken the original image and you've dropped off a bunch of patches and you've kept only a few of those patches. So we have a few of those patches, and now you take this image and you pass it through the ML model and you say, what is the probability that it is a frog? And we basically get a bunch of probabilities. Now, based on these probabilities, now we know what parts of the image were included. And now we can look at what is the most important parts of the image that allow us to say that this is a frog or not a frog. So you basically do know based on the presence or absence of a patch, how much does it impact the ultimate prediction. That now gives you this thing that says, this is the part of the image that the model really focuses on to identify that this is a frog. Okay? So that's the way that these methods work in terms of of explaining why a machine learning model produces the output that it does. What part of the image is it focusing on to make the prediction that it does? Okay? The second approach, this is integrated gradients. The basic idea behind integrated gradients is that when you train an ML model, it basically, the error rate, right, drops a lot and then slowly plateaus. Why does that happen? Well, it happens because a lot of the model initially focuses on the most informative part of the image, the part of the image where the gradient is the greatest. So what we are now doing is that we start with a baseline image, and the baseline image can be, say, all zeros. And then we basically take all the, interpolate images between the baseline image and the original image. And for each of those images, we go ahead and we compute what the prediction is, and we look at the gradient. And we now know, right, basically at every pixel, where does the gradient change happen the most, right? And we can now look at which parts of the image cause the greatest changes in the gradient. And then we can basically take those pixels, and we still know that those are the pixels that were the most important for the model to basically identify whatever it is. So in this case, for example, this is a panda, and the model basically looks at the snout of the panda and the fur of the panda to decide that this is a panda and not some other kind of animal. You can also look at it in a very very compelling example, is that here's a baseline image, here's the original image of a boat with like water squirting out of it, and the model says that this is the fireboat. How does it know it's a fireboat? What is it looking at? Well, it's looking at the jets of water. The fact that there is a bunch of jets of water is what basically tells a model that this is a fireboat. So now it's like we kind of trust this model now. We say, okay, that's what it looks at. That makes sense. Like, you won't normally have boats that basically do not have like the water coming out of them. And if there's water coming out of it, it must be a fireboat. So that's the basic idea behind integrated gradients. So two methods. You have LIME, which basically looks at patches and finds which patches are important by running the images through the model. Integrated gradients, which looks at how much the gradient changes along the way as it basically does it. So X-ray is a combination of these two things. And this is kind of the state of the art today. The idea is that rather than take these patches that all have similar pixel values, what if we take those patches and then we look at the integrated gradient in each patch, and then we start to combine patches based on whether or not they have the same kind of gradient or not. So now we basically get patches that are more holistic. So now we basically, they're more like a region. And then we take these regions and we essentially do the same thing that we do in kernel SHAP. We drop a few regions and we run it through the model, and we figure out what the probability is. And we use that to rank the regions. And that's how we get our explainability. Okay? So those are the three methods as far as explaining a prediction is concerned. There are also other methods that exist that I'm not going to get into, but this one, for example, is called TiEcon, and it's a way to explain how during training, how does a model basically learn. So for example, is this image a zucchini or not, right? The error rate drops dramatically when the model sees this particular image, which is labeled as zucchini. And right, so this is what is called a opponent. It basically, this is how it knows that this thing here, looks nothing like this image, and therefore it gets the correct label, and then goes on until it sees this particular image, which looks a little bit like this thing, and therefore it basically, the loss starts to go up. And so we start to find what are called proponents and opponents, things that basically improve the error rate or decrease the error rate. And so we can now find a bunch of images where the direction of the loss changes. And that gives you an idea of how does the model basically figure out or learn the correct label for any particular image in your training data set. Okay, but we will focus primarily on the X-ray aspects. You have a prediction, you have a trained model. How do you predict it? Okay. So now, how do you actually apply Lime or X-ray in the real world, right? So I'll show you how to do that in Google Cloud. So the idea is that you already have a prediction model. And the way, whenever you have a model and you deploy it with what is called a serving signature or prediction signature. So in this case, we have a prediction signature that says, if the user gives me a file name, now I'm going to basically tell you what's in that file. So that's the API that we are actually putting out there. This is a web service API. Input is a file name and output is the category that's in the image. Okay. So in order to do this, there are two parts to this. There is a pre-processing part where we take the file and we read the image, we scale it, we resize it, we do all of those kinds of operations to it, and we get a pre-processed image. And then we send that image to our trained machine learning model. So that's our XAI model. So what you do is that you basically break your model into two parts, okay? The pre-processing part and your model part. And once you do that, the reason that you're doing this is, remember again, the way that X-ray works, we need to basically go ahead and the explainable routine is going to break it down into patches and call the model multiple times. So what we're doing is that we're basically providing that model so that we get called multiple times, not just on the original input image, but on all the perturbed images, and all the changed images. So we create this method that calls our original model that basically pulls out the actual result, the probability, the classification category, etc. So the normal TensorFlow code that we normally write, we write that, okay? And having done that, the next thing that we need is, again, step back to the way this works, is that with integrated gradients, you need a baseline image and the original image. And remember that with X-ray, we need both integrated gradients and the patches. So we need a baseline image to basically find the difference in gradient off. So what is our baseline image? That's a choice that you have to make. It could be all zeros, it could be all ones, it could be the background of your factory floor without any parts in it, whatever you want, right? In this case, I'm basically creating a baseline that consists of random numbers, white noise, right? And I'm basically saying, here's my white noise, that's my baseline, here's my actual result, how does it change in between them? Okay? So once we do that, right, now we send results as normal to the REST API. We basically have our images, we have our file names, and we say, please go run my prediction on it. But what comes back is going to contain, in addition to the normal result that you have, this is a flower, it's a daisy, it's a probability of 0.5. In addition, you're going to get back an explanation. And you can go ahead and parse those explanations. And in that explanation is going to be an image, right? And you can basically go decode that image, and that explanation will look something like this. So here's the original image that we sent, and this is the explanation that we got, and this is integrated gradients. So these are the parts of the image that have the maximum gradient in them. So when we look at this, it looks like the model has focused on this particular part of the image and this particular part of the image. Or when it looks at this dandelion, it is focused on the center of the dandelion and one part, because all the rest are pretty much the same. It basically just focused on a few of the petals. Or when you look at the daisy, it's very clear that it's focused on the petals of the daisy. On the other hand, when you look at the tulips and the cat, it sees the tulips, but it also sees the cat. Okay, so it's basically looking at both of them, and it's kind of confused a little bit. It has to go figure out which one is the actual flower in the image. So this is integrated gradients. And the difference between the second row and the third row is that they're the exact same thing. I've just done one minus the other, just so that you can see, black on white or white on black, right? So in some cases, the pink is much easier to see. In some cases, the green is much easier to see. So just two ways of visualizing that information. On the other hand, if you did X-ray, what you would get would be regions. Notice in particular this particular image. So here's this image. The difference between X-ray and IG, this is integrated gradients. Line will give you very similar kinds of things, right? So this is basically, there's not, it says it's focusing on all of these things, but X-ray, man, it tells you this is exactly what I'm focusing on. I'm focusing on that one prominent flower in the image, period. The model has learned to ignore all the background. Same thing with the dandelion, right? It focuses on these kind of black and orange stuff, and it basically focuses on the white petals. Look at the daisy, it's beautiful. It's focusing on that bright segment, right? That's in that bright yellow thing. That's what makes it a daisy. Like lots of flowers have white petals, but not the only daisies have that yellow band, and the model is basically learned to focus on that yellow band. Great. But then you also know, okay, the model doesn't do well on this image, and you kind of see why. What is a model doing? It's focusing on the most prominent thing in the image. And what's the most prominent thing in this image? It is that bright eye of the cat. And yep, that's what the model focused on. And that's why the model gets a little bit confused. It's looking at the most contrastive thing in the image, and that happens to be the eye of the cat. When it comes to tulips, it basically says, oh, there's a bunch of flowers that all look alike. These must be tulips, right? And that again makes a lot of sense. So let's look at, like I'll go ahead and do a demo that shows you like how this actually looks. And again, this is out of our book, right, on practical machine learning. It's early release in O'Reilly. You should basically get it in a couple of months. So basically what I'm going to do is I'm going to say, let's go ahead and run it on AI Platform Notebooks. And it's going to ask me which notebook instance I want to run it in. If you don't already have one, you can create one. But you can create a new notebook instance. But here I already have one. So I'll say, let's just go ahead and please open it in that. And it's going to basically open this notebook in that AI Platform Notebook instance. And once I have it in that instance, I can now go ahead and run my model, right? So I can say, please run this line of code, right? Load this checkpoint, and load this model that I've already trained. So in this case, I'm starting from an already trained model. So again, as I mentioned, right, we basically have a whole bunch. This is a book, right? So it basically starts from how to create an ML model, how to create a data set, pre-process, train, etc. We are now way down here where we've deployed the ML model, and what we are now doing is we're basically getting an ability to load that model from the checkpoint that we've already trained it. And then what I'm doing is, having loaded the model, I'm changing its prediction signature. I'm changing the prediction signature so that it does the pre-processing and it does the model calling, right? And then writes it all out with 3 different prediction signatures: the original default, the pre-processing method, and the method itself to call the model. So once this is done, it's going to take a little bit of time because it's an image model. Image models are large. They have to get loaded from that checkpoint. It's like 140 different layers in this model. It's going to take a while. So while that's going on, let me just walk through what this actually looks like. Okay, so we can also actually look at it here as well. Okay, so we've now done this part. We've loaded the model, right? And at that point, we can now look at the model signature. We can say, show me the model signature. And now TensorFlow will tell us that there is the original serving default, which takes a file as input and basically has 3 outputs: the type of flower it is, which as an integer, as a string, and the probability, which is a floating point number. And then you have the XAI model, which takes not the file as input, but a tensor that is 345 by 345 by 3. Why 345 by 345 by 3? Well, that's because when we trained the model, we trained it with that image height and that image width. Okay, so then it also basically provides the same output. The pre-processing method takes the file name and creates that 345 by 345 by 3 tensor. So that's basically what we have. And then once we have that thing, we can now go ahead and say, here's a bunch of images. please go ahead and load this model from my serving default and run it for me. And it will come back and say the first model, which is actually a dandelion, right? It'll basically come back and say the first one is a dandelion. The second one is a dandelion. The third one is a daisy. The fourth one are tulips. And fifth one are tulips. So in this case, the model got all 5 of them correct. And it basically has a probability of each one of them, right? The first one is a dandelion with a probability of 0.39, for example. Now, what we can also do is that we can say, let me go pre-process that image. So I'm just sending that image and I'm calling the pre-process method, and the output is going to be a 345 by 345 by 3 tensor. And I basically get that exact tensor that I want. The next thing that we can do is we can basically go ahead and say, let's create my random baseline. And I basically put my random baseline in a JSON file and I deploy it to Cloud AI platform. When I deploy to Cloud AI platform, the one key thing that I do is that I basically say that I would like you to add explainability. Use X-ray as your explainability method. Do 25 steps between the baseline and the actual image. So we pass that explainability when we deploy the model. And then once the model is deployed, we can now pass in our original image, and we can basically get back the normal probability. But we can also ask for an explanation on the image. And when we ask for an explanation of the image, we will get explanations that we can then go ahead and we can plot the explanation, and we will basically get the image that I showed you in the slide. And 1 minus that explanation is this other image that I showed you in the slide. So the same thing we can do for a different, like, this is IG. We can do that for X-ray. And when we do that for X-ray, we will get these images, okay, and so on. Okay, so let's see if this is done. So that has been loaded. This one's done. We can now go ahead and do the saved model. It's going to show us what's in the saved model, right? Exactly what we showed you. And then we can now go ahead and, run, for example, the prediction. So let's go ahead and do this. Pre-processing, for example, is basically going to load up, do the pre-processing, come back with a tensor. Okay, so it's all of the output that I showed you. I won't bother like going through this all over again. But if you're doing the Qwiklab, you will get to basically run through this notebook and see how it works. Okay, and again, the way you can get to the Qwiklabs is by you should have gotten an email when you signed up for this session. So check your mailbox with whichever email you signed up for, and you should get 30 days Qwiklabs access and a $300 Google Cloud credit. In particular, the 30-day Qwiklabs access, you can basically go to Qwiklabs.com and search for explainable AI, and you should be able to basically get like labs, right, for doing the explainability. I talked about the what if tool. You also have other image explanations from Google Cloud Platform. So this is again a way in which you can go ahead and try this out.
Lak, this is Lalit here. So I also posted the link to our Google landing page, Google TiEcon, in the chat.
Okay, perfect.
Thank you.
Perfect. Thanks, Lalit. So you can go ahead and try this out. Okay. So go ahead and try that out. And with that, I will take questions. So let's see if there are any questions in the chat. Okay. The book is scheduled for release in November 2021. Is there a way to get an early preview of the book? Yes, absolutely, right? So just go ahead and search for Practical ML Vision Book O'Reilly Early Release. And there it is, right? So if you go in there, okay, show the table of contents. So, it's, I think, first 3 chapters may have been loaded there. 4 chapters. Actually, chapter 4 is actually chapter 5. So yeah, so half the book is already there, and over the next few weeks, more of the book will show up. We've already finished the book and we've turned it into O'Reilly, so it's in press right now. Hopefully, you will get more and more of it. Okay. For Lime, what would be the right definition of neighbor? For example, tabular data versus text strings. Is there a suggested way to search for optimal neighbors in TensorFlow? If you want to find optimal neighbors, I would not use Lime at all, right? There are much better techniques that exist for doing search. Okay, so it's called, now there's a method, again, we go through this in the book. It uses something called a triplet loss image search or image retrieval. So this is basically the technique that you would use, right? Image similarity using triplet loss. So don't use Lime if what you want to do is to find neighboring images or similar images. Use the triplet loss approach. And I think we covered that in like chapter 12 of the book or chapter 11 of the book. So I hope that answered your question.
So,
any other questions?
I have a question, if I
Sure.
may ask. So, when it comes to explainable AI, do you have something called like monitoring the data drift? So, it's based on certain model, and as the data changes, how do you know whether things are working properly or not?
Absolutely. That's a great question, Lilith. That is called continuous evaluation. And it's not part of explainability, right? The idea is that you can basically go ahead and do continuous evaluation. You deploy your model, and then what you do is that you set up a sample, and the sample predictions and the inputs get saved into BigQuery. And then what you can then do is that once you have the ground truth, you can basically set up this graph to be created, and then you can look for model drift. So when you're looking for model drift, what the feature that you're looking for is continuous evaluation. Right? So two different things, right? So what I've been talking about is AI explanations, but for continuous evaluation, if you want to do this kind of monitoring of your model performance over time, look for the continuous evaluation.
So for the audience, please ask questions. I mean, Lak is an expert on data engineering side as well as machine learning. So this is your chance.
Yeah, and so if there's, if you want to go ahead and ask me in chat, that is fine as well. I guess that's the only way, right, Lilith? They don't have an ability to ask orally.
Correct. Yeah, one other thing, like while we're waiting for questions, right? So we asked in the opening keynote today about the impact on data, right? I mean, it's a generic question, but for explainable, there's no dependency on data volume or anything, right? It's just it has to be cleaned up, and then that's it.
Yeah, absolutely. Again, I think we talked about it a little bit. We said there are two types of explainability, right? You have the global explainability, and you have the instance explainability. Okay? The global explainability is very much dependent on your entire training data set. So you're trying to do things like feature importance on your entire training data set. And the more data you have, the longer this is going to take, etc. The instance explainability is on one image at a time, right? That has no relevance to how much data you use to train your ML model, right? So there's two types of explainability. It's kind of good to keep in mind that they do different things. The feature importance is much more around what is important for my model as a whole, whereas the instance explainability is what is important for the model on this particular item, not the model as a whole. On this particular item, why did the model do what it did? Okay, and they're both important. Okay, so the global importance is going to be important whenever you want to basically figure out whether a particular data point is useful to include or not. Because as we know, every time you add an input to an ML model, there's a whole bunch of data engineering pipelines you have to build. They have a cost to them. So you might decide that, the loan amount is not that important, so let me just drop it, and then I don't have to worry about all the PII information associated with the loan amount. And that can be a significant savings, and you're willing to sacrifice a little bit of model accuracy because you don't want to basically commingle things. Or you might decide the loan is not that important, let me just round off the number. So now I don't need to know the exact loan amount, I just need to know the bucket that falls into. That is a kind of decision that you make out of global explainability. The instance explainability is more about troubleshooting and bias busting and trust building that I talked about.
Okay, great.
Okay, cool. We have one more question, I guess, on the chat. Okay. In addition to GCP, who is good at explainable AI? Well, I mean, all of the methods that I talked about are all open source. Again, and that's developed at Google, yes, but we've open sourced it. So Tracin, X-Ray, etc., are all open sourced. So you can run them anywhere, right? So you can, it's all TensorFlow, it's all open source. You can run it anywhere. What Google does is that we basically give you a good managed experience and so on. But it's if you're not using Google Cloud, that I'm not saying that you cannot use explainable AI. You totally can. It's all open source, so I just encourage you to go try it out. You have to install things and you'll have to play around with them a little bit, but that's about it. Okay. How well does the model work on medical images such as X-rays? When it comes to medical images, tends to be that IG, integrated gradients, works a lot better than X-ray. Right? When I showed you our example of flowers, I think we talked about two methods. We talked about IG and X-ray. And in this case, X-ray is so much better than IG. When it comes to medical images such as X-rays and MRI, IG tends to be better than X-ray. Okay, so that's why you have both methods, right? So you want to basically pick and choose. Which areas of AI should aspiring AI engineers focus on? It really depends on the kind of industry that you want to go work in, right? I mean, this is just like software, right? ML is becoming more and more infused into organizations. And just like people say, it is much better to be an expert on finance who knows programming than to be a programmer who knows finance. That's going to be the same case with AI. It's going to get to the point where it's much better to be a domain expert who can do AI than to be an AI expert who kind of dabbles in the domain. So what I would suggest is, if you're an aspiring AI engineer, pick an industry, pick like if you're going to be working in healthcare, or you're going to be working in finance, or you're going to be working in retail, learn that industry, become a domain expert in that industry. And then you basically think about what problems there are in that industry. If you're talking about retail, most of the problems are around time series forecasting and recommendations. So those are the two AI fields that I would focus on. If you're working in medical, on the other hand, a lot of the problem sets are around patient outcomes and on image analysis. So those are the two areas that I would focus on: structured data and images. Right? So it really depends on like that. So that's the order in which I would go. I would first pick which industry that I want to work in, and then go look at the AI problems in that industry and focus on those AI problems. Hopefully I answered that. Okay. Next question. Can the basic principles be extended to videos as well? Yeah, totally, right? So it's the same IG technique works whether you're basically doing text or using images or using video. The same ideas totally work, absolutely. Okay. I guess the next image is the same. Next question was the same thing. Do these explainability features address regulatory concerns of the use of AI or make AI more usable in healthcare? In our experience, it has been the case that adding explanations does help, right? It helps foster trust from physicians. It helps address some of the regulatory concerns. A lot of the regulatory concerns are around patient privacy, etc. And this doesn't address those, but it addresses some of them, right? So I would not say that it's like a blanket statement, but it moves the needle in the right direction. Okay. Any pointers on explainable AI for NLP models? Absolutely, right? So basic idea behind explainable AI for NLP models is today look for the attention mechanism, right? NLP attention mechanism. Okay. And that's the attention mechanism is basically what people use. like to kind of understand where is the model basically looking at. So no, I don't have a good reference to suggest, but this is the general area here that you're looking for. You're looking for the attention mechanism and NLP models. Next, is there research trying to apply explainability techniques to data augmentation? Sort of, right? It's kind of like with the start thing I talked about with foxes and snow, for example. And I said, once you find this problem, the solution is data augmentation. But I don't think that it's been automated in any way, right? But definitely the directionality, the way you develop the judgment to troubleshoot ML models, that's totally the case. And data augmentation is a solution to problems that you find through explainability analysis. How about the oil exploration industry? How is AI applicable there? I have seen AI applied in a few places in the oil industry. One is on seismic images, right? So a lot of petroleum exploration firms have tons and tons of seismic imagery, and being able to do automated analysis of those is hugely important, right? So you basically have a lot of stuff around seismic images. The next application area I've seen is around choosing the correct experiment, correct equipment. Right, the right size of pipe, the right power involved in your drilling equipment, etc. Because like no one can actually have everything on hand before you go to a particular site. So before you start drilling, you want to say, what kind of equipment do I need to have on hand? And being able to predict that can basically help you with a lot of logistics. The third thing that you've seen is your typical stuff around prediction of volumes, prediction of good prospective locations, etc. But the two main things are seismic images and basically predictive analysis. And the predictive analysis is also around equipment. It's also around predictive maintenance of equipment, especially things like offshore equipment. You want to basically figure out how often do you need to go out and go do maintenance on it. How can AI be used to the maximum in professional football? There's a whole field on sports analytics, right? There's a ton of work on sports analytics, everything from identifying which players do well in what situations, doing play analysis of basically doing stuff around doing AI to identify where the ball is, where the different players are, extracting out plays. There's an amazing I don't know where you are from when you say professional football. I don't know what you're talking about. European soccer, for example, or you're talking about American football. But if you're talking about American football, there's a great data set on Kaggle that basically is a play-by-play data. It's great. So it's a really interesting data set to go play around with if this is the football that you're talking about. Please advise in the cybersecurity industry. Yeah, on the cybersecurity, there's a lot of work around virus, right? Basically, the thing is it's a cat and mouse game, right? So you're basically going ahead and you're trying to basically identify if a particular piece of software has a virus or something hidden in it. And that analysis is very much anomaly detection, right? So you're trying to see, is this like things that we've seen in the past, or is it fundamentally different? You're trying to do matching, you're trying to do anomaly detection. So those are the kinds of problems that happen a lot in cybersecurity. But the challenge in cybersecurity is that you basically, it's a cat and mouse game. It's like everything that the white hats find, the black hats figure out a way to basically get around it. So cool. Can this be used to identify deep fakes? I don't know what you mean by this. Assuming it is machine learning, can machine learning be used to identify deep fakes? again, this is one of those things where you have the generative adversarial networks. In essence, the second part of a GAN is a way to identify deep fakes, right? So identify fakes. Well, can it be used to identify deep fakes? Well, the whole point of a deep fake is that it's managed to fool the GAN, and the GAN is thinking that this thing is real, which is why it came out. So now you basically, a deep fake is essentially a fake that's managed to fool a GAN. Okay, so that's what makes it really challenging. Okay, let's move on. These are great questions. Explainability of emotion for images, say in retail. Okay, if you're trying to find emotion in images, you do not need explainability. Instead, you will have a labeled data set where you would have labeled emotions as joy, as sadness, etc., right? And then you would basically train your ML model to do that. Having said that, there are significant ethical considerations when it comes to emotion and images. So different cultures express emotions differently. You will find it, again, this is an area in which you have to be really careful, right? So be very careful about emotion and images. It's yeah. So I'll stop there. It's not as easy as explainability. It's not as easy as classification. There are a lot of considerations here that you will want to think through before you start to build anything like emotion and images. Next. Interesting new approaches to content recommendations, or is this mostly solved? The state-of-the-art approaches to content recommendations these days are hybrid approaches that combine content-based recommendations, collaborative recommendations, and deep learning-based approaches. And it's this combination of things that's used for content recommendations, and it's not solved as such, but it's really hard to wring out incremental improvements beyond the state of the art. Okay, I work for Google. There is something called the recommendations AI. Okay, which is a very turnkey method to basically, you have your product catalog, you have the user transactions, and we can basically create recommendations. And it's really, really, really hard to get beyond this off-the-shelf kind of thing. So if you're doing recommendations, I encourage you to basically take a look at the off-the-shelf methods, at least to benchmark your approach. Any suggestions for some trying to develop an AI program to read handwritten language documents containing a lost language? Yeah, the issue there is like, how do you get a large enough data set? Okay, probably again, I've not looked at this problem too much, but my immediate suggestion would be, is this lost language similar to a language that currently exists, and can you do transfer learning from that language and fine tune it on the last language? Oh, and the deep fake question. Can we use explainable AI to identify deep fakes? Probably not. Probably not. Because what the model is going to tell you is what it focused on. And the idea behind a deep fake is that you're trying to basically find out what the model hasn't seen. That's the only way that you know what's, again, because fakes are created through GANs, and a deep fake has essentially come out of a GAN. It has fooled the GAN, the generative adversarial network. It's a hard problem to automate. It's a hard problem to automate. And I think we're getting close to the end of the time. Okay.
We have 5 minutes, but it's up to you.
Oh, okay. Okay, cool. Okay. Ethical questions aside, is an AI-based polygraph test on videos feasible as state of the art? I have no idea. I really don't know how how good polygraph tests are, let alone polygraph tests based on video, right? I don't know. I don't know. Okay. How would you use AI to create blog posts and help with SEO using the data tables? Yeah, I mean, there's this whole deal about we can generate text with AI, but I've never seen generated text that looks great other than for very specific use cases like translation or summarization, where the creative problem is not there. The problem with creating blog posts is that you're expecting AI to be creative. And I don't think AI is creative. AI is a great way to basically take a bunch of old data that it has seen in the past and kind of compress that data and so on. But creativity doesn't, I've not seen it work well. Okay, so that's again, maybe. Maybe this will change. Maybe this is like favorite, like that's what we think today, and then like 2 years from now, somebody comes up with a way to make AI a lot more creative.
Hey, Lak, I have a quick question. So, just a chance to promote GCP. I know you said Explainable is open source, but there has to be some value. Why use AI?
Yeah,
Explainable.
I mean, it is open source, but it's going to be super hard for people to set up and use. And like the way I showed it, it is basically when you deploy a model into AI platform, essentially you get explainability for free. We handle all of the hard work in terms of perturbing the images and running them and making sure that it's auto-scaled, that it's available when you need to on demand and all that. Yes, you can run the code yourself, but there's always a big difference between self-managed and fully managed, right? And the reason that we open source everything is because we don't want to lock anybody in, but we believe that the environment and the software and the hardware and all of that well integrated is worth a lot, right? It's worth a lot more than the time that you're gonna spend trying to set all this up yourself. And again, we have engineering teams, security teams whose only job is to make sure that this thing runs as efficiently as possible, as securely as possible. When people set things up themselves, that is a load that you take on, right? That I would argue is not something that you as an ML developer shouldn't have to take on the load of running these systems. I mean, there's a reason why nobody runs their own web servers and email servers anymore. We end up using web hosting systems and we end up using email servers. Managed services have a lot going for them. Okay, so that's why we're not too concerned about saying this thing is open source. Yes, you can do it, but the managed service is so much more convenient and so much more cost effective.
Okay, great. So you have maybe time for 1 or 2 questions and then we'll wrap up.
Okay, so I saw a whole bunch of questions coming in. Let me just go. Yeah. Can we connect with you offline with implementing our company's AI? We're using GCP and the entire Google Tech stack. Absolutely. Just reach out to the salesperson who's basically working with you. I mean, one of the cool things about working with Google Cloud is that we work hand in hand with our customers. If you're a GCP customer, I would love to hear from you, right? But it's not just me, but there's lots of engineers in Google, right? So again, if you're on Google, definitely reach out to your technical account manager, reach out to your sales rep. They should be able to basically get collaboration going. Anu also said the same thing, right? So we're all here. I think our day is done when we make a customer successful.
So I think, sorry, Lak, we have a grand keynotes after this. So
yeah, absolutely. Thank you.
Yeah, I would say, Enrichment, if you have any questions, if you want to reach out to the Google guys, just contact us and we'll connect you to the right people at Google, just in case you need some help. So just quickly, again, this was really awesome. Basically a very good overview on Explainable AI. And I think for the audience, we have I've provided the link for Qwiklabs. You have 30 days to finish the AI skills challenge, and whatever Lak went through, you can go by yourself. But we wanted to just have Lak actually go over live, which is very valuable, and then we give a chance for you to follow up in next 30 days. So thanks again, Lak, for a wonderful event. Thanks to Anu as well for covering document AI. And just later on, we have a grand keynote starting right now by Geeta Fisker, who's co-founder and CEO of Fisker Inc., and Adina Friedman, who's president and CEO of NASDAQ. We all know NASDAQ. So we have a grand keynote right now at 11:30.